We're going to be going over calculating the volume of this composite part. Now this part, as you can see, we have a rectangular prism up here. We could kind of break that down to a rectangular prism up on the top, then a rectangular prism down here on the bottom. Then you can see that we also have two cylindrical cutouts as well. And so what we're going to end up needing to do is we'll need to find the volume of this rectangular prism. We'll need to also find the volume of this rectangular prism on the bottom. And then we're going to need to find the volume of these cylinders, and we're going to actually subtract the volume of those two cylinders from there. So there's our three parts. So what we can go ahead and do is we can start to write this down. So I'm going to start by doing step one. And step one is we're going to add the volumes, or find the volume of this base piece. Okay, so here's our base piece here that I'm drawing out, right? Now, let's go ahead and dimension this out. 0.5 inches is the height. And then what we've got here is this width here. And then the depth, if we go back onto here, we can see that it's 1.25, right? So 1.25 is the depth, all right? So now we can find the volume of this, right? So the volume of this, if we end up going into our equation sheet, you might not have this memorized yet, right? But you can find this by taking the height times the width times the depth. And so in this particular case, it's going to be our height, which is 0.5 inches, times our width, which is 2 inches here, and then the depth is 1.25 inches, right? And so now what we've got for the volume of this bottom part is it's basically going to be a half times 1, or times 2, which is going to end up being 1, right? 1 times 1.25 is just simply 1.25. Now if we have a unit of inches, times a unit of inches times a unit of inches, that's going to end up giving us a unit of inches cubed. Please remember volume. Most of the time, if we have a linear unit here, like inches, we're going to end up cubing that, right? So it could be cubic inches, it could be cubic feet, could be cubic meters, could even be cubic yards or cubic miles even, right? So most of the time, our units are cubic if it's a linear unit on there. So that's the volume of our bottom piece here. Now what we can do is we can also find the volume of this top piece. And so if we end up going through here, bingo, there we go, then we can end up finding the volume of this top part. So now I see that this total height here is 1.75. What I can do is I can subtract this half of an inch here, right? Because we just want this top part here. So this is going to be 1.25 by 0.5 by 1.25. So let's go ahead and let's start to draw that out. So this is the part that's actually going to be resting on top of this, right? So we've got it where it's 1.25 inches, then this is half of an inch. This is going to also be 1.25 for that depth. So there we have it. So this is 0.5 inches, just as we said. This is 1.25 inches down here. So 1.25 inches. So now we're going to basically add this volume on top. So volume here is going to be in our height, 1.25 inches, right? Multiplied by our width, which is half of an inch, multiplied by our depth, which is 1.25 inches. And so now whenever we multiply this out, we're basically going to end up with 1.25 squared, right? Just because it's 1.25 times 1.25 times 0.5. So now that ends up giving us 0.78125 inches cubed. And so now we have this bottom piece here, the volume of that. We have the top piece volume. Now all we've got to do for our last step is we got to find the volume of one of these cylinders. And then what we're going to do is we're going to basically subtract two of those cylinders from this to find the total volume, right? So what I'm going to do now is I'm going to go ahead and draw out one of these cylinders here. I'm going to try to do the best job that I can drawing out this cylinder. And so here's our cylinder. Now what they say for our particular case, remember this is going to be different for you because it's randomly generated, is the radius is 0.33 and then our depth is actually pretty close. And so just because I want to end up having this look a little bit more to scale, we can go ahead and create this, make this look a little bit better. So it's going to end up actually looking something along these lines, right? Where our radius is 0.33 and then our depth is 0.34. So I'll go right here to right here, 0.34 inches. Radius here, we can do that call out. Radius is 0.33 inches, okay? So now let's go ahead and let's calculate this out. What you might be wondering, oh, Mr. Rainbow, I don't know the volume of a cylinder. Well, if we go to our good old equation sheet, equation 4.10 ends up telling us that the volume is equal to pi r squared times h. So this is V equals pi r squared times h, right? Now in this particular scenario, we've got the radius equal to 0.33 inches. We're going to square that. Then we need to multiply that by the height, which is 0.34 inches. And so now this ends up working out where we take pi. Remember, you go second on your TI-84, you press second, and then you can press this little caret top button right here. That'll give us pi. So we've got pi times 0.33 inches squared. So that squared is going to end up going to the 0.33, and it's also going to square our units. And then we're going to multiply that by 0.34 inches. Once we have all that multiplied out, we'll end up finding that the volume is going to be equal to 0.11632. Now, what unit are we left with? Just as we were saying, it's cubic inches. Now, just like before, we had inch times inch times inch. That gives us inch cubed, right? This particular scenario, since it's 0.33 inches squared, that squared is going to end up being distributed to 0.33 as well as the inches unit. So that's actually inches squared times inches. That gives us cubic inches. So this is the volume for just one of these cylinders, right? And so now to find the total volume, right, which is what I'm going to put right here, total volume is going to be equal to, well, 1.25 inches cubed, right? Because that's our top or our bottom piece here of that. We're also going to have this top piece, which is 0.78125 inches cubed. And then what we're going to do is we're going to subtract 2 times, now why are we subtracting? It's because these are cut out of our parts, right? 2 times 0.11632, and that's going to also be in cubic inches, right? So I kind of ran out of some room there. So we'll just put TV, total volume. That's going to be equal to 1.25, so 1.25 plus 0.78125 minus 2 times 0.11632. That's minus 2 times the volume of a single cylinder, because we have 2 of those. So what we end up finding for the total volume is it is equal to 1.79861. Now if I want to go to the nearest, or if I want to go out 4 decimal places, since this 5th decimal place is a 1, we're going to go ahead and round it down, and then this is going to be in inches cubed. And so that is how we end up finding our total volume. So just as a recap, what we did is we ended up taking this initial part, we broke it down into simpler parts where we have the bottom piece, the top piece. We found the volume of those 2. Since we had 2 cylindrical cutouts, we ended up finding the volume of one of those, and then after adding these 2 volumes together, we end up subtracting 2 times this value because there were 2 of those cylinders that were being cut out of the material, and that's how we end up with our final answer of 1.7986 cubic inches. Hope that was helpful. If you all have any comments, questions, concerns, please drop them in the comment section, and as always, like and subscribe. Thank you all so much. Bye-bye.